Welcome, deep divers. Have you ever looked at a building and truly wondered, really wondered, what goes into its making? Beyond the visible facade, there's an entire universe of decisions, a rich tapestry of history, the science of materials, and just an immense amount of human ingenuity at play.
It really is vast.
Today, we're embarking on a deep dive into the very essence of how we build, how we live within those structures, and critically, where the future of our built environment is headed.
It's remarkably easy to take for granted the spaces we inhabit every single day, isn't it?
Oh, absolutely.
But once you start to pull back those layers, you discover something far more profound than just bricks and mortar. You uncover, a rich tapestry of philosophy, the meticulous precision of engineering, and even the subtle yet powerful dynamics of social interaction embedded in every wall and every roof.
Yeah.
Our mission today is to unpack this incredible complexity, giving you a shortcut, really, to understanding the profound and often unseen impact of architecture and construction on your daily lives.
And what a journey it will be. We've gathered a fascinating stack of sources for you today, a real intellectual feast.
Definitely looks like it.
We're drawing from everything, from ancient architectural treatises that laid foundational principles to modern project management guides outlining today's best practices, and even visionary looks into the future of urban design. It's a journey that will span centuries, intertwine with technological advancements, and ask that fundamental question. What if a building could be more than just shelter?
More than just shelter.
Yeah, what if it could be a living, breathing, evolving entity? So let's unpack these layers and discover the hidden forces shaping our world.
Let's do it.
To truly appreciate where we're going and the innovations that lie ahead, we have to start by understanding where we've been.
Makes sense. Got to know the history.
For centuries, buildings haven't just been functional structures. They've been profound statements, embodying the deepest aspirations, cultures, and philosophies of their time.
They absolutely have. If we cast our minds back to the earliest monumental structures, like the temple at Thebes in ancient Egypt, as vividly described in our sources, you find architecture that was meticulously organized, not just for function, but for a deliberate sensory and spiritual experience.
So how you felt moving through it.
Exactly. Imagine walking along the grand avenue of sphinxes, the central axis, through towering pylons, vast, sun-drenched courtyards, each leading with a sense of escalating grandeur, culminating in the innermost, most sacred sanctuary.
Wow.
The very plan itself, its careful progression and monumental scale, was said to carry the very essence of sensation. It was designed to evoke awe, reverence, and a profound journey.
A narrative in stone.
Precisely. And similarly, in ancient India, the Buddhist carver builders at Karli, these are in the Western Ghats, they regarded the act of sculpting their taitya, that's a type of sacred Buddhist prayer hall, often carved right out of the rock.
Amazing.
And their holy shrines primarily as a rite, a sacred act of creation and devotion.
Ah, so the building was the ritual.
Yes, it demonstrates this profound, direct connection between the physical act of construction and deeply held belief systems. For these early builders, the structure was the ritual. Its creation, its form were acts of worship.
That's a powerful distinction. Building not just as shelter, but as ritual, as experience. But, in our hyper-rational, efficiency-driven modern world, has that spiritual or ritualistic aspect been entirely lost? Or does it just show up differently?
That's an excellent question. I think it probably manifests differently. We might not perform literal rites, sure, but the aspiration to create spaces that inspire or calm or connect us to something larger, that definitely persists.
Like museums or concert halls, maybe?
Exactly, or even community centers designed to foster connection. They aim to evoke specific sensations, much like the ancient temples. But to trace how these foundational concepts evolved, we really need to look at classical architecture next. That's where the idealization of form truly took hold.
Right, ancient Greece.
In mainland Greece, yes. The stone temple, particularly in its Doric order, those sturdy fluted columns with the simple capitals.
Yep, iconic.
It emerged not merely as a functional structure, but as an ideal invention. And this wasn't just like translating earlier timber forms into stone, which is a common assumption.
Oh, interesting.
It was actually a highly sophisticated reinterpretation, a restatement of religious architecture's principal theme. Greek architects, as Viollet-le-Duc reminds us, focused on expressing effects inspired by wood rather than just trying to petrify them exactly into stone.
So, interpretation, not copying.
Precisely. They interpreted architectural rules rather than servilely followed as a flock of sheep. They sought to fulfill exact conditions, make the building's purpose obvious, and use sculpture not merely as decoration.
But as adornment.
Exactly. Adornment that underscored and enhanced the building's intrinsic meaning and function. It was about principles, purpose, and a profound intellectual engagement with the material. That's a key insight for any designer today, really.
It's fascinating to see how that intellectual engagement shifted over time. Our sources highlight a critical moment, early 20th century, when some architects deliberately rejected what was known as the machine aesthetic. What was that aesthetic, and why turn away from it?
Okay, so the machine aesthetic, big in the early 20th century, it championed a stark, functional, often unornamented style. It celebrated industrial processes, geometric purity, mass production.
Steel, concrete, glass, that kind of thing.
Exactly. Gleaming steel, concrete, vast glass facades, often designed with this almost rigid adherence to mechanical efficiency. But Rainer Banham points out that rejecting this specific aesthetic led some people, he calls them established modern deadheads, which is quite colorful, to mistakenly assume a wholesale rejection of technological culture itself.
Ah, so they threw the baby out with the bathwater.
Kind of, yeah. It was a critical misreading. What was truly abandoned wasn't technology, but stylistic prejudice. Moving away from the idea that one single machine-derived look was the only valid expression of modernity.
That sounds freeing, actually.
It was incredibly important. It opened the way for a more viable, integrated approach to design, the concept of the style for the job.
The style for the job. I like that.
It meant architects could admire, as Banham puts it, peasant houses on Santorin and the chromework on Detroit cars with equal fervor.
Wow, quite the contrast.
Right. They weren't confined anymore. They could appreciate and draw inspiration from forms suited to their function and context, whether it's vernacular wisdom or slick industrial design. The insight is that real innovation often comes from appreciating utility and context, not rigid style rules.
So the style for the job freed architects from dogma. And if there's one figure who consistently reinvented his style for the job, it's Frank Lloyd Wright, right? His evolution seems to mirror this.
Absolutely. Wright's career is a compelling testament to this continuous evolution. He was definitely not a resolute exponent of a single philosophy.
No kidding.
As our sources say, the first Mr. Wright and the last were different kinds of architects. Early on, before 1909, he had the Prairie School style, low roofs, open plans, strong horizontal lines echoing the landscape.
Like the Roby House.
Exactly, or the Larkin Building. Revolutionary stuff, rooted in sight and function. But then later you see him designing things like the Guggenheim Museum, all curves.
Totally different.
Or Falling Water, embracing organic architecture, growing right out of the landscape. Throughout these shifts, though, Wright consistently criticized superficiality. He emphasized that good architecture should be an embodiment of truth, beauty, and a response to the environment and human needs.
Not just a costume.
Precisely, a genuine expression of life. And he notably felt a strong disinterest in traditional European styles, really pushing for a distinct American architectural identity. His journey wasn't about finding one truth, but a lifelong search for authentic, responsive architecture.
Okay, here's where it gets really interesting for me. As traditional styles were reevaluated, the philosophy shifted. What new forms and ideas emerged, especially with new materials like steel and glass?
Ah, yes. The 20th century, fueled by the Industrial Revolution and these incredible materials, saw radical transformations in what architecture could even be.
Like the Le Corbusier.
Le Corbusier, absolutely. Famously, provocatively declaring, "The house is a machine for living in."
Which sounds kind of cold, but what did he really mean?
It wasn't just a catchy phrase. It represented a paradigm shift, advocating for architecture optimized not just for design and structure, but explicitly for mass production and social function. His 5 points of architecture, the free facade, open plan, they became foundational to modernism, freeing buildings from load-bearing walls.
Right, changing the whole game.
Totally. And you also see Walter Gropius's Model Factory in Cologne, 1914. He used expansive glass walls instead of traditional closed partitions.
Letting the light in.
Exactly. It brought novel brightness to industrial architecture, flooded workspaces with natural light, and offered a more humane interpretation of the factory compared to earlier, often grim industrial buildings.
So it wasn't just about looks, it was about the experience inside.
Definitely. And these movements, powered by the strength of steel and the transparency of glass, truly shattered previous limits on scale and form. Visionary engineers like Isambard King-Brunel,
Bridges, steamships.
Sir Joseph Paxton with the Crystal Palace, almost all glass and iron.
Incredible structure.
And Gustav Eiffel, obviously, with his tower pushing wrought iron to its limit. They all designed these daring and innovative structures that just shattered the limits of what could be constructed.
They really did.
They didn't just build, they created a new aesthetic at the nexus of architecture and engineering, where the structure itself became part of the beauty. They showed that engineering isn't just about making things stand, but redefining what's possible and creating new kinds of beauty in the process.
Okay, so we have these incredible visions, these evolving aesthetics, but none of it happens without the nitty-gritty details, the unseen structures of engineering and material science. What are some of the fundamental challenges in making these ambitious designs actually stand up and, last?
That's a profoundly important question, isn't it? How do we ensure stability, safety, and longevity? Our sources get into the core principles of structural engineering. Take beams, for instance.
Okay.
They're rigid members designed to carry and transfer transverse loads that's weight applied perpendicular to their length, like a floor or roof across a space to support.
So they bend under load.
Right. They're subject to bending and deflection. The material inside has to resist enormous tension at the bottom and compression at the top. Columns, on the other hand, mostly carry axial compressive loads pushing straight down.
But they can buckle, right?
Exactly. They're susceptible to buckling, a sudden sideways instability. The Euler formula helps predict this, and crucially, how a column's ends are restrained, pinned, fixed, or somewhere in between significantly affects its load-bearing capacity. Fixing the ends can multiply its strength.
Wow, that much difference.
Oh, yeah. And even something seemingly simple like a riveted joint, once common in big steel structures.
Like old bridges.
Yeah, bridges, boilers. It can fail in multiple ways. By shearing the rivets, snapping them.
Okay.
By tearing the rivets out of the plate, called bearing failure. Or by tearing the plates themselves. For high-class work, they even punched rivet holes undersize and then reamed them larger.
I do that.
Precision, yes, but also to reduce brittleness and tiny cracks near the hole that could compromise the joint. Shows the detailed material understanding needed even back then.
It sounds like the choice of material is absolute critical, down to the tiniest detail of its properties and how you handle it.
Precisely. The inherent properties dictate everything. Take wood. Different species like oak, cedar, walnut have distinct characteristics. Understanding terms like diffuse porous wood versus ring porous wood, like oak.
Okay, what's the difference there?
It's about how the water-transporting vessels are distributed in the growth ring. It affects how the wood performs, how it might warp or weather, and dimensional stabilization. Treating wood to minimize shrinkage and swelling with humidity changes, that's crucial for long-term integrity.
Prevents cracking and loose joints.
Exactly. Even the design of a nail head matters for its withdrawal load. A common nail's broad head resists pulling through the top piece better than a finishing nail's small head.
Never thought about nail heads that way.
Right. And for masonry, concrete blocks, or brick, factors like density, fire resistance, even local quarry sources like Stonesfield slates in Oxfordshire or Purbeck marble in England, they've shaped building traditions for centuries.
Define the look of whole regions.
Absolutely. And going way back, Agricola's 16th century De Re Metallica. It gives astonishing detail on ancient mining and metallurgy, describes tools, refining copper and silver. It highlights how deeply rooted material science is in building history.
Yeah.
Understanding properties has always been fundamental.
Beyond the basic structure and materials, how do buildings interact with their environment? What does that mean for design and construction today?
This is where building science becomes absolutely critical. Moving beyond just stability to creating comfortable, durable, healthy interiors. Protecting the building envelope, the exterior skin, is paramount.
The roof, the walls.
Exactly. Roofs need meticulous design not just to shed rain quickly, but also handle snow loads, manage water with gutters and downspouts. Proper roof ventilation is essential too.
Why ventilation specifically?
To prevent ice dams in cold climates. That's where meltwater refreezes at the eaves, backs up under shingles, and seeps into the structure. Big damage potential.
Nasty stuff.
And walls need sophisticated layering air barriers to control airflow, vapor retarders to manage moisture. Joseph Listaberg's guide highlights a key principle. Assemblies need protection from exterior wetness, obviously.
Keep the rain out.
But critically, they must also be allowed to dry towards the interior. Often using permeable interior finishes lets trapped moisture escape safely. It's a constant battle against the elements.
And what happens when these systems, these layers, aren't considered holistically, or when people take shortcuts?
Stuart Brand offers a crucial cautionary tale here with vinyl siding.
Oh yeah, seems so
It
practical.
was marketed that way, a solution to peeling paint, decayed wood, promising low maintenance, but it often creates far more insidious problems.
How so?
Vinyl siding acts as a chilled vapor barrier. It traps moisture behind it from small leaks, wind-driven rain, even interior humidity.
Uh-oh.
And because it's cold on the outside, you get condensation. It creates this perfect environment for structural damage to happen invisibly for years. Wood sheathing rots, mold grows.
You don't see it until it's catastrophic.
Exactly. Brand argues for the forgivingness of traditional materials like shingles or clapboard. They're permeable, they move with temperature changes, and crucially, they look bad before they act bad.
Meaning they show wear and tear?
Right. Peeling paint, minor deterioration, it signals problems before the structure is compromised. It raises a philosophical question. Do you want a material that looks bad first, giving you a chance to fix it, or one that acts bad long before it looks bad?
That's a really good point.
And this principle extends everywhere, including vulnerable points like windows. Brand notes they often obsolesce quickly from fashion swerve and technology advance and won't last 20 years. They're moving parts, seals, exposure. They're constant wear points.
And overseeing all of this structure, materials, the envelope, are building codes, often seen as tedious, but absolutely foundational, aren't they?
Foundational is the right word. Far from tedious, they're critical documents, constantly updated, rigorously enforced. They set minimum standards for life safety and property protection.
Based on lessons learned, often the hard way.
Exactly. Often tragically. Codes dictate everything. Fire resistance ratings for beams and columns, wall finishes, requirements for sprinkler systems depending on occupancy.
Like a hospital versus an office.
Precisely. They specify the minimum number and capacity of exits per story, ensuring safe evacuation. Understanding and adhering to codes is the non-negotiable framework for all construction to safeguard the public.
Okay, shifting gears a bit. Beyond the physics and materials, building these complex structures isn't just about steel and concrete. It's a massive human endeavor.
Yeah.
It requires intricate coordination, negotiations, understanding people.
It truly is. Our sources from the Project Management Institute, especially the PMBOK guide, underscore a vital truth. Stakeholders permeate all aspects of the project.
They're not just waiting for the end result.
Not at all. They actively define requirements, shape planning, determine acceptance criteria. A huge part of the project manager's job is engaging and communicating with stakeholders. Their influence runs from concept right through to outcome. You ignore them at your peril.
That sounds like a constant, delicate balancing act, especially with so many different voices and needs.
It absolutely is. Project managers continually balance various stakeholder needs and priorities, which are often complex, sometimes conflicting, always evolving.
Leading to trade-offs, I imagine.
Frequently, balancing budget versus aesthetics or schedule versus quality. The PMBOK guide highlights key principles for this. Demonstrate leadership behaviors, inspiring trust, not just giving orders. Tailor based on context. No one-size-fits-all approach. Build quality into processes.
Not just inspect it at the end.
Exactly. And crucially, embrace adaptability and resiliency. Be ready to adjust the plan as things change, rather than sticking rigidly to a blueprint that might be outdated. Constant vigilance, flexible execution.
So it's not just following a blueprint, it's leading a dynamic process, like conducting an orchestra.
An excellent analogy. Construction management involves this continuous cycle, measuring, monitoring, and comparing actual efforts with estimated inputs and adjusting the plan accordingly.
Keeping things on track.
Right. Often using tools like the critical path method, CPM. It identifies the longest sequence of activities, the critical path, which sets the project's minimum duration. Any delay there delays everything.
But it also shows where there's flexibility.
Yes, it reveals float, extra time. An activity can be delayed without impacting subsequent activities or the final deadline. Understanding float helps managers allocate resources strategically and mitigate unexpected delays on non-critical tasks. Powerful tool.
And when we look at how the industry itself is structured, it's not always a symphony, is it? Lots of different players, often operating quite independently.
You're right, it can feel more like different sections playing in isolation sometimes. The construction sector is diverse building, engineered, industrial construction. But as Stewart brands how buildings learn details, the traditional process is often highly fragmented.
How so?
Architects design, hand off to engineers, structural, mechanical, electrical, plumbing, often working separately. Then it goes to a general contractor who subcontracts out maybe 80% or more of the work.
And the subcontractors have the specific skills.
They often have cutting-edge technical skills, yes, but they're frequently too far downstream to affect design. This dispersion of responsibility, these information silos, lack of early communication, it leads to problems.
Right.
Brand mentions buildings being too hot in the winter and too cold in the summer because insulation, HVAC, windows weren't considered holistically from the start by everyone involved. Leads to inefficiency, discomfort.
That fragmented approach sounds inefficient and, frankly, frustrating. Is there a better way? A way to foster collaboration?
Our sources strongly suggest yes. Collaborative behavior can be actively fostered by things like integrated project delivery, IPD contracts, and lean construction processes.
IPD and lean.
Yeah.
How do they help?
They fundamentally shift how teams work. One architect called them always a carrot, never a stick, meaning they incentivize cooperation. IPD, for instance, brings owner, architect, contractor into a multi-party agreement early on, sharing risks and rewards, aligns everyone's incentives.
Makes sense. And lean.
Lean focuses on value creation, waste elimination. A key tool is the Last Planner System, LPS. It aims to improve workflow reliability through structured collaborative planning.
Like weekly plans.
Yes, coordinated weekly work plans, look-ahead planning to remove constraints before they cause delays, and pull planning, working backward from milestones. The goal is learning how to do what we say we're going to do. Much more predictable, efficient, higher quality.
This whole discussion of process improvement, individual responsibility in a large system, it makes me think of Peter Drucker. His management insights seem really relevant here.
They are indeed highly relevant, especially for quality in construction. Drucker argues that for any worker, sweeper to executive, to achieve, they must first take responsibility for their job.
Okay, and what does that require?
According to Drucker, productive work, the job is designed for results, feedback information so workers know how they're doing, and continuous learning. He critiques managerial incompetence when work isn't studied, processes aren't synthesized, standards aren't thought through, or information tools aren't provided.
That resonates strongly with construction quality control.
Absolutely. A contractor's quality control plan is essential. It ensures adherence to measurable standards, dimensions, tolerances, test results, installation temperatures, achieved through inspections, field tests, lab tests, all documented meticulously.
So quality isn't an accident.
Not at all. It's a systemic outcome of clear standards, empowered individuals, and continuous feedback, just as Drucker suggested.
And sometimes the human element takes on a much grander, even political scale in shaping our cities, for better or worse. Not just managing projects, but wielding immense influence.
Indeed. Robert Moses, as depicted in Robert Caro's The Power Broker, is a powerful, if controversial, example.
The master builder of New York.
Master manipulator of power, certainly. His ability to navigate hostile landowners via eminent domain, leverage vast federal funds like calling partways park access drives to get federal labor.
Clever, in a way.
And even engage in public smear campaigns against opponents. It shows an unparalleled capacity to push through his monumental projects. His expressways, bridges, parks fundamentally reshapes New York's physical and social fabric.
He was hard to stop.
Caro shows he was often too big to fire, even when mayors or presidents tried. It highlights the immense, sometimes unchecked power individuals can wield in shaping infrastructure and urban landscapes, leaving a complex, lasting mark.
We've traveled from ancient rituals through modern engineering, project management, even political power plays. Now, let's fast forward. Look around the corner into the future. What's next for how we design, build, and inhabit our world?
We are definitely in what Neil Gershenfeld calls the third digital revolution. And it's not just about computers. It's characterized by universal fabrication.
Universal fabrication, meaning?
Meaning not just designs, but the act of making things moves from analog to digital precision. Gershenfeld's work highlights the exponential growth of fab labs, community labs, giving people access to powerful digital fabrication tools.
3D printers, laser cutters.
Exactly. And these aren't just production facilities. They're nuclei for fabrication communities, doubling every year and a half. It indicates a huge shift towards localized, accessible manufacturing, empowering individuals.
So making things smarter, closer to the user, More customized?
Precisely. The vision involves merging multiple machines and processes, focusing on the assembly and disassembly of discrete building blocks.
Building blocks. Like Lego.
Sort of. The aim is to close the loop from production to consumption and back again, reducing inputs to a small set of modular parts that can be reconfigured or broken down, replacing recycling with a reversible process of disassembly.
So you could take a building apart and reuse the pieces easily.
That's the idea. Minimal waste. It could realign production with daily life, letting manufacturing exit the factory, maybe back into local workshops or even homes. It evokes historical parallels like medieval cottages or Kyoto's mafia, which combine dwelling and fabrication.
A much more sustainable, user-centric model.
Transforming every citizen into a potential maker of their own environment.
That sounds like our buildings could become much more than just static containers. They could become truly responsive, dynamic entities.
They absolutely could. We're moving towards what Carlo Ratti calls living architecture, buildings as an extension of the body, actively sensing and responding to us.
How would that work?
He envisions a cybernetic program in spaces of dynamic interaction, enabled by cyborg tools, embedded sensors, actuators, smart materials, and real-time information flows, connecting the Internet of Spaces with the Internet of Bodies.
Internet of Spaces and Bodies.
Wow. The goal is seamless interaction where technology recedes into the background and interaction is brought to the fore. Imagine a wall subtly changing temperature or transparency based on who's in the room.
Or a public space reconfiguring itself.
Exactly. Creating environments that feel intrinsically vibrant and alive, integrated with human biology and intention, not just automated.
What's fascinating here is how all this data, this Internet of Spaces and Bodies, connects back to people and communities, potentially empowering them.
Indeed. The flood of urban big data from transport taps, social media offers fertile ground for research, theory, and practice. What we inferred before, we can now immediately sense on a huge scale in real time.
Addressing big questions about how we live.
Absolutely. From social science dynamics to urban planning trends. This data signals a profound reorientation of knowledge and power, empowering citizens to think, act, and transform their public space. Ratti emphasizes, no smart city without smart citizens.
Echoes Jane Jacobs.
Definitely. Her insights that city people depend greatly on their neighborhoods and need means for civilized self-government. The convergence of data and community participation holds promise for truly democratic, responsive cities, but it needs active, engaged citizens.
With all this complexity, interconnectedness, feedback loops, smart systems, can we truly control these systems, ensure they serve our best intentions?
That's a critical question. Donella Meadows, the brilliant systems thinker, addresses it directly. She says, self-organizing, nonlinear feedback systems are inherently unpredictable. They are fundamentally not controllable.
Not controllable. That's a big statement.
It is. The idea of making a complex system do exactly what you want, optimizing everything. Meadows argues that's achieved only temporarily at best. We can't fully understand our world in that reductionist way. We can't optimize everything because we often don't know what to optimize, or optimizing one thing messes up another.
So what's the alternative?
Moving away from the illusion of absolute control towards humility and adaptation. Embracing adaptability and resilience, recognizing there's always more to learn, and multiple perspectives and rich understanding. For designers, it means creating robust systems that can fail gracefully, adapt to change, not brittle systems designed for one perfect outcome. Humility in the face of complexity.
So navigating this uncertainty requires technical skill, systems understanding, and ultimately human wisdom.
Exactly. Samuel Foreman, in The Existential Pleasures of Engineering, advocates for engineers to be sensitized and liberally educated to account for the imperfections and the absurdities of his fellow human beings.
Engineering with a human touch.
Yes. He sees a poetic vision in it, a creative drive. He notes women often bring a heightened appreciation of the humanities to the field, potentially stimulating socially and philosophically breakthroughs alongside technical ones. It's a call for a holistic, human-centered approach, integrating technical prowess with understanding human nature, societal needs, ethics, building not just structures, but a better world.
Well, that was quite the journey, from ancient rituals evoking the essence of sensation, through digital fabrication to living architecture. It's clear the built world is far more than just bricks and mortar. It's a dynamic interplay of human ambition, scientific rigor, philosophical shifts, and our ever-evolving social needs.
We've definitely seen how design isn't just aesthetics. It's performance, safety, emotional impact. We've touched on the intricate dance of project management, the need for collaboration, and the power individuals like Robert Moses wielded, a reminder of the huge responsibility involved.
And as we look to a future of smart cities, citizen makers, buildings as extensions of ourselves, the lessons from history, insights into complex systems, understanding human dynamics, they become even more vital.
Which really raises an important question for you, our listener. In a world where our buildings get smarter, more responsive, where physical and digital blur, what new responsibilities do you have? As an inhabitant, a potential future crafter of your own environment, how do we ensure technology serves our deepest human needs? Connection, beauty, sustainability, rather than just creating more efficient yet perhaps soulless boxes.
Something profound to ponder as you look around at the spaces that surround you today. Thank you for joining us on this deep dive.